Hey, feeling good, like I should. When in dark, walk around the neighborhood. Feeling blessed.
All right, let's take a look at our homework for lesson 8.1.2. This is the lesson where we learned about how compound interest works and how it involves exponents. And so what are exponents? Well, exponents, this is called the power, 2 to the 4th power. Oh, that's exactly what I had in the notes too, isn't it? Interesting. Okay. So this is the power where the base is the number that gets repeatedly multiplied. So if you look here, the base is the a. And the exponent, that is the n, which would be telling you the number of times that you repeatedly multiply a number. So 2 to the 4th power is going to be 2 times 2 times 2 times 2. 4 times 4 is 16. So this is a shortened version of the number 16. All right. Rachel's been given $1,000 put into a savings account. She earns, all right, so that's principal. There's our principal, $1,000. Interest rate is 2%, and 2% in decimal form is 0.02. And what are the terms? It is simple interest. That's good to know. So we're going to use I equals PRT. And Rachel hopes to buy a car. Oh, it's every month, isn't it? So in 2 years, 2 years is going to be 24 months. So we will put a 24 here. So which, what does it say? Rachel's determined, or she needs to determine whether she will have enough money to buy a car that costs $1,500. So in 2 years, will she have enough money? Will her $1,000 have grown enough to be able to afford this payment? So I'm going to figure out how much she is going to earn per month. So I'm going to take 1,000 and multiply it times 2%. That is $20. That means that she is going to make $20 per month. And now I'm going to multiply that $20 times 24. And that's how you get $480 is the amount of interest that she is going to earn. So when you add that to the amount of money that she had deposited into the account, she's going to have a total of $14,800 to withdraw from that account. But she's still going to be $20 short. But it's better than being $500 short. So yay for Rachel. Good financial planning. All right, copy and complete the table at the right using for powers of 10. Use the pattern in the completed table to decide how many zeros 10 to the 7th will have and how many zeros 10 to the 23rd will have. Okay, so what's the pattern here? In standard form, 10 to the 0 power is technically equal to 1. And when we get into exponent rules, we're going to explain, I will explain to you why that is the case. Anything to the 0 power is always going to be equal to 1. 10 to the 1st power is 10, 10 to the 2nd power is 100, 10 to the 3rd power is 1,000, and so on and so forth. So what pattern are we noticing here? Dear, 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 near, do, there, and there, and there. So this only works for powers of 10, nothing else. But the exponent tells you the number of zeros that are going to be in standard form for that number. So 10 to the 5th power has 5 zeros, and the number that has 5 zeros there is 100,000. So 10 times 10 times 10 times 10 times 10 is equal to 100,000. So that means that 10 to the 7th will have 7 zeros, and that's going to be like 10 million. And 10 to the 23rd is going to have 23 zeros, and I don't know what that number is called, and I don't care. So how would you tell someone to write 10 to the 50th power? Well, start with a 1, right? All of these have the number 1 at the beginning because it's a 10. And then the number of zeros would be 50. So have fun writing 50 zeros in that number. And it's for really large numbers like this is one of the reasons why we use exponent form. And so we can sort of round off the number and write it as a power. All right, Jack noticed a sale on his favorite model of all-terrain vehicle. The salesperson said the company was cutting the price 8%. Wonderful. If the usual price is $4,298, then how much is the discount going to be? Okay, so it's an 8% discount. So you could think about it this way. You could say, well, 10% would be about $430 because that's almost 4,300, and 5% would be half that. So you know it's got to be somewhere in the mid 300 range, right? The halfway point between those two. But to me, it's just so much easier. Let's just find out what 8% of that number is by changing 8% to its decimal and then multiplying it times 4,298. So 4,298 times 8% in decimal form is $343.84. So that's going to be the exact amount. We were asking for an estimate, so your estimate in the 350 range seems reasonable. So now calculate the amount Jack did pay with the 8% discount. Well, we already know how much it got marked off, right? So we'll just take $4,298 and subtract away $343.84, and that gives you this amount here. Or if you recall, when we were talking about percent increases and decreases, if you are paying, or if you're getting a 8% discount, the original price minus 8% means you will be paying 92% of the original price. So what happens if I take 4,298 and multiply it times the decimal equivalent of 92%? 4,298 times 0.92, there's our answer. So just like when we were doing markups, like sales tax, if it was 8% sales tax, you would take 100% plus the 8%, and you could charge 8% and add it to the original, or you could just multiply this times 1.08 or 108% to get the new amount. The same thing applies for decreases or discounts. We did this in 7th grade. 100% minus the discount gives you the percent that you were actually going to pay, which is the sale price. So if the store sold 3 ATVs that weekend, how much money was saved by the 3 customers? Okay, well, we go back to the amount of the savings, triple it, and it ends up being this number right there. All right, the choir's planning a trip to the water park, and the parents are trying to determine how much to charge each child. The cost of the bus is going to be $350. So it doesn't make any difference how many people are on the bus. The bus costs $350. So if 10 people are on the bus, if they split it evenly, they each pay $35. If 20 people are on the bus, 20 times $17.50 is $350, or $350 divided by 20 gives you $17.50. If 35 people ride the bus, each one would pay $10 because 10 times 35 is $350. And then this is kind of an odd dollar amount, but if you took $350 and divided it by 15, you would see that every person would have to pay $23.33. So thinking back to working with proportions, is this proportional? And the answer is no, it is not proportional because it did not grow by a constant rate, and 0, 0 doesn't apply, although technically it does, I suppose, because if nobody rides the bus, nobody's paying any money, right? But someone's got to pay the $350. That's the thing. If you went through the trouble of securing the bus and paying $350, someone's got to pay it, right? So this particular graph looks like this. That's a horrible line. I'm so sorry, but it's really hard sometimes to do it with my little Moby kind of a thing. But this is how that graph would look. And this graph is what we call an inverse variation, y equals k divided by x, where k, which is normally that constant, remember the constant of proportionality, that's the price of the bus. So neither x nor y can ever be equal to 0 because you can't have 0 in your denominator. So this graph is going to forever go closer to the x-axis, but it'll never actually get there. And this will always go forever closer to the y-axis, but this will never actually get there. So that's what this nonlinear kind of a graph looks like, and it's associated with inverse variations. All right, fraction operations. I'm going to let you contact me if you need to work through any of these. You know, common denominators are necessary when you're adding, and then it just comes down to you're adding a positive to a negative, so you subtract the numbers and keep the sign of whatever fraction had the greater value. Here we're multiplying, so when you multiply two numbers that are different signs, you'll always get a negative answer, and then it comes down to you multiplying numerator times numerator and denominator times denominator. All right, looks like a dilation here. Graph these points on a coordinate grid and connect them. So that would be the blue triangle. Then it says dilate to a scale factor of 2. So each one of these is going to get doubled, right? So 0, 1 becomes 0, 2. 3, 2 becomes 6, 4. And 2, 4 becomes 4, 8. What do you notice about the side lengths? Well, what color should I do? This side length is twice the length of this one. This side length is twice this one, and so all of the corresponding side lengths are twice as long as the original. Because if you recall, when we're dilating shapes, the scale factor actually applies to the linear measurement. So each line, corresponding line, will be twice the length of the original, and the perimeter of the new shape will be twice as long as the perimeter of the original. And that does it. Is this a bit shorter than yesterday's? Yes, it is. So only 11 minutes, much, much better. All right, take care. Let's move on to the next activity. Bye.
Hey, feeling good, like I should.